Good afternoon, everyone. Welcome to our webinar on low volume roads. My name is Christy Little. I'm the Programming Training Coordinator at AORS. First off, I want to thank you all for joining us on this third day of National Public Works Week. With the third of our 5 webinars that AORS is pleased to bring you this week alongside some fantastic partners. Together, we're going to be discussing important issues impacting municipalities and public works professionals across Ontario. As we did yesterday, I do want to begin by taking a moment to recognize and thank each and every one of you for the impact that you have on your communities across this province. The work of municipal public works professionals often goes unnoticed, and when it is noticed, unfortunately, it can sometimes come in the form of negative feedback. The reality is that your work is often thankless, but our communities could simply not function without you. From maintaining the critical infrastructure and protecting our environment to ensuring safe roads, reliable services, and healthy communities, the work you do matters immensely. You truly are the public works superheroes of your communities, and National Public Works Week is an opportunity for us to celebrate and recognize the incredible contributions you make every single day. Today, I am pleased to introduce our presenter, Dr. James Smith from Good Roads. James is the Manager of Technical Services and Research and is Good Roads Authority on any type of road, from gravel to asphalt to bridge and road-related infrastructural design. It's hard to imagine anyone more passionate about road design, so it's truly entirely appropriate that James leads Good Roads' science-based research on road building and infrastructure. James is also adjunct professor of engineering at the University of Guelph. So without further ado, I will pass it over to James. Just a reminder before we begin, there will be a question and answer session at the end of the presentation. Welcome to put any questions into the chat throughout the webinar. I'm going to be monitoring those as we go along. Additionally, this webinar is being recorded. You would have heard me start that at the beginning. And that link will be sent to all of those who are registered. In addition to that, James, I think, was going to put some of this information, today's presentation, into a PDF for you that we will share as well. There's some links that you might find appropriate later on, so we'll look forward to sharing that as well. James, the floor is yours. I think I did mute you though, so I apologize.
Yeah. Thank you so much for that, Christy. I want to thank you and also Kelly for the opportunity to actually present to your colleagues today. So it's a wonderful opportunity. Let me bring up my presentation. Do that. It works so well in practice. There we go. Oh, so great. Share screen. Okay, technical glitches out of the way.
Looks good.
All right. Again, thank you for the opportunity. It's great to be able to participate as part of AOR's promotion of National Public Works Week and then their webinar series. As mentioned, I am James Smith. I'm the Manager of Technical Programs and Research with Good Roads. What I hope to talk to you today is focus on really 2 things, those being the reduced load periods and also kind of rural road safety. 2 things that are of great importance at Good Roads and really affect what we do in public works throughout the entire year. So my outlines here on the screen, there's several subtopics within each of those. And I'm also going to leave you with some additional resources. These are things that I use a lot, if not on a weekly basis, but I guess, again, on a weekly basis, sometimes it might be a little longer, but used in answering a lot of the questions that come in from municipalities across the province. So kind of beginning, reduced load periods, or RLP, really, why do they matter? And this really boils down to the need to protect our municipal roads from damage during that thaw period. And really, it applies to all of our roads. It's not discriminated against type. We see anywhere from really a 50 to 70% loss, potentially in bearing capacity during this time. The lower end, that 50%, that's kind of more in line with our asphalt pavements. At the upper end, the 70%, that's gravel. And if we have surface treatments, they may fall somewhere kind of in the middle, around that 60% bearing capacity loss. So again, we're seeing a loss of strength. And it's really important due to the fact that we know that heavy vehicles cause exponentially more damage. But really, how do we quantify that? So there's really a number of ways that we can do that. The easiest or most simplest is the fourth power law. It's really been around for the longest, where in simplistic terms, really, if we double the load, we're going to see 16 times the amount of damage. So we're doubling the load, so a factor of 2 raised to the fourth power, that we end up with 16. Our second way of really measuring load equivalency of quantifying that damage is the load equivalency factors. So this is trying to quantify that pavement damage really due to what was deemed a standard truck axle. So 8,160 kilograms, or if we convert, 8,000 pounds. This was introduced in the late 50s, early 1960s during the AASHTO road test. It has been updated since for the Canadian environment in the mid-80s during a vehicle weights and dimension study. The use of load equivalency factors is basically, it's an empirical process. So it's based upon observations and experimental data that is then used to identify trends, draw conclusions, and ultimately build a model. The third method is by far the most advanced, the mechanistic or pavement ME design, or mechanistic empirical, is really the state of the art. That's what is being used by provincial authorities across Canada, like the MTO, our large cities. Universities are doing a lot of research with this tool, and also consulting firms across the province. And what we see here, again, state of the art. So we're taking our material properties, 1, 2, our climatic data, and also traffic data, looking at, axles and their spectra. And this is applied then to our pavement structure that is either in place or that we're designing for. And through thousands and thousands of iterations, we monitor the stress strain response to each one of those materials in our road, the asphalt, the aggregates, the base and subbase. And we see what happens is the accumulation of damage over time. And then this is then turned or manifested into what we see as distresses, or cracking, rutting, etc. So that's really kind of how we go about quantifying the damage. But it's important to balance what we're doing with in terms of RLP, in terms of protecting our pavement, but also with fostering economic activity. So we have competing goals of prolonging our pavement lifespan, reducing our maintenance costs, but we also want to maintain that economic activity. So really, under the reduced load periods, what we're seeing is the potential to make more trips due to reduced loads that we can carry. That's going to take or use more fuel, increase our CO2 emissions. It's going to require more driver hours and potentially longer distances. Something that highlights this is if we look at a cement truck. Typically during construction season, your standard cement truck may be carrying anywhere between 7 or 8 cubic meters. During this reduced load period, that's usually down to about 2. So they're going to need to make anywhere between 3 or 4 extra trips to carry that same amount of concrete to the job site. Now, all winter snowfaring nations, really except one, have or deal with reduced load periods. That one exception, Norway. Back in 1995, they removed all axle restrictions from their national and county road networks. This was done to improve the efficiency of the network. They made it work by providing additional funding to those areas of the pavement that failed during this time to upgrade the structural capacity. And as of recent, there has been no indications by Norway that removing the load restrictions has impacted the serviceability of their roads. And in fact, through the upgrading of those weakened sections, overall, they're seeing an increased life cycle of up to 5 years of those pavements. Traditional decision making around RLP. So this is really what we have as the status quo. So reduced load periods are mentioned in the Highway Traffic Act, Section 122, whereby a municipality has the ability to implement reduced load periods, and it's done through a bylaw where defined start and end dates are provided, and that maximum axle weight, I guess 5 tons. Again, 5 tons being 5,000 kilograms. It's also important to notice that that 5,000 kilograms is less than that standard axle that was used in the one way that we calculate damage using load equivalence factors. Now, when we look at kind of times historically, what we see across at least Southwest and Central Ontario, dates that would range from March 1st till the end of April, April 30th, or that may be extended into mid-May. As we shift farther north, those dates can be shifted by really up to a month, and sometimes will even run into June. Under this current sort of status quo, the way that we do things, we see inconsistent timings across municipalities that makes it difficult for industry at times to plan routes. Then we also have the added complication or risk that depending on our fixed dates, we may apply too early, too late, and on the other end, remove too early or too late. And so we may end up with a non-optimal timing. There we are. The last thing I kind of wanted to highlight about kind of the traditional reduced load period decision-making process was to highlight a study that was done by the MTO back in 2021. So there was a lot of inquiries by municipalities for advice on how and when to apply these dates specifically. As part of that, the MTO did this survey. There was 270 municipal respondents that replied. And of that, there was some key things that came out. At that time, 61% of the municipalities were still using a fixed date approach. However, within this 61%, about a third were also combining that with what we're going to call institutional knowledge, where your road supervisor, public works engineer, somebody else was looking at modifying those dates based upon, I guess, observed weather and also historical trends in terms of observed strength. The survey also highlighted that there was 25% of those 270 municipalities that were using variable dates, so that we're not starting from the basis of those fixed dates. And we're allowing, based upon past historical records, that institutional knowledge or some other methods, potentially having an RWIS system and being able to know exactly what was happening with their pavements, we're doing something different. And at the time, that study again, also, I guess the last point, 65% of those that responded were attempting to coordinate with adjacent municipalities. With that, it's, I guess, important from our perspective now that the MTO has their reduced load period tool that Good Roads is distributing on their behalf. The importance of really redoing that survey to quantify the impact of that new model and tool. So really, what is that MTO model? We're going to take a little bit of a deeper dive into that. So again, MTO is being asked questions of when, by municipalities, when to do that. or when to apply, remove, and they're also wanting a better understanding on when to sort of apply and remove those dates for some of their own lower volume roads. So looking for uh, a scientific justification of really when to do that. So what happened was they began with a jurisdictional scan. So they were looking to what other provinces and states were doing that had similar climatic zones, looking for comparables. Three that really stood out: Manitoba was using something called the cumulative thaw index, or CTI. I probably should start by explaining what that is. And that's really the cumulative, there we are, number of degree days when the air temperature is above 0 degrees. So we see the starting of thawing of our pavement structure and the number of days that's going to sort of carry on for. So Manitoba as a province, again, using CTI, and their reduced load periods were in place for approximately 12 to 13 weeks from the start. Ultimately, the MTO determined this was potentially a little too conservative. There was also Minnesota that was using CTI also, and what the way their program was working, the reduced load periods would be in place until the road was completely thawed, plus an additional 3 weeks, or up to a maximum of 8, where this was kind of viewed as maybe a little too aggressive, and there'd still be potential damage that could be caused implementing a method like this here in Ontario. Quebec also did something a little unique, kind of looking at thaw depths, looking at the amount of time that it would take for the thaw to move from 30 centimeters to 90 centimeters, and then there'd be an additional 5 weeks to allow for the thawing of the structure to occur. This, although a great method, was quite intensive in what was going to be required in terms of monitoring and equipment to build a model around across the province. So ultimately, it was decided upon the cumulative thawing index, and through the data that they collected back in 2022, set about setting up their specific program. So there was a lot of data that was collected in 2022 looking at kind of RWIS, or road weather information systems, kind of looking at temperature, air, pavement temperatures, moisture, and frost depth. They also conducted or had drilled a lot of holes to look at determining the exact pavement structure and confirming that RWIS data in terms of kind of frost depth. Then there was also falling weight deflectometer testing, kind of looking to determine and monitor the strength of the pavement and subgrade during this thawing period. So with all that information, the MTO settled upon 4 zones. So these were kind of grouped similarly across the province, taking into consideration things like soil type, frost depth, what type of asphalt cement was being used in those regions. Then within each of those regions, there was a number of weather stations that were used to build or populate those models from. So kind of really focusing on choosing those RWIS sites, so we'd have real-time monitoring of atmospheric and also pavement condition data. And with that, again, with 4 zones, we have also the thresholds for when to start and end those reduced load periods that are shown in the table, I guess on the right hand of our screen, where we see we're beginning the onset really at the same start, those 8 cumulative thaw index values, and then where we see a change in when they're removed, those CTI threshold days. Zone 4, again, being Southern Ontario, where it's going to thaw the quickest and return to its strength because we see lesser frost depth and more favorable conditions. The MTO model. No presentation I give is complete without some form of calculation. So this is the first time we're going to sort of see these in this presentation. What this boils down to, the MTO created a simplistically simple model based on everything that was discussed on our previous slide, and boiled it down to being only the need to correlate air temperature, both using a daily maximum and a daily minimum. What we're going to do quickly is see our calculations, our formulas on the right-hand side of the screen, sorry, the left-hand side of the screen. On the right, we have a sample from zone 4. I'm going to walk through kind of these quick calculations quickly, kind of looking at the February 16th date. Things that we need to calculate. So our calculated daily air temperature. From our formula, we see what we're taking as our daily maximum plus our daily minimum. We're going to divide that by 2. So we have a maximum value of 3.5, a minimum of 3. We're going to add those together. We're going to get 0.5 divided by 2. We end up with 0.25. So under our calculated row, we see a value of 0.3. That's the Excel file, just simply rounding that. Next, we have our reference temperature. Instructions on really how to go about that. Again, we start with a value of 0.06 degrees Celsius on February 1st, and it's increased by 0.06 degrees every day. So February 16th, we're 16 days in. It's essentially 0.06 times 16, or a value of 0.96. That's our reference temperature that we see, again, corresponding to February 16th. Next, the thawing index. The formula we use really depends on whether that calculated temperature is greater or less than 0. Here we have it being greater, so we're going to calculate it simply by adding that calculated air temperature, that 0.25, plus our reference temperature, and we end up with 0.21. We simply round again to a value of 0.2 or 1.2. So really, how does Good Roads fit into this picture? The MTO has a model. What's Good Roads' role? So one of our functions is that we really exist to connect our members, so Ontario municipalities, to each other, to other levels of government and relevant companies in the private sector, really to help improve municipal infrastructure. We have worked in the past with MTO on initiatives such as the bridge funding program, where money flowed through Good Roads in exchange for data or condition data on their bridges. This was in the early 2010s, and we've partnered with the MTO in other projects since. So what we have really is providing to all 444 municipalities and also our First Nation groups the ability to access the reduced load period calculator tool that the MTO developed. It's available on our website. Our weekly updates from February all the way through June. We do provide updates at least twice a week, happening Monday, Friday, and there's also the goal of updating at midweek, kind of Wednesday, which has happened, I think, for the most part of this reduced load period season. Now, with the tool, there's also some available online training. This is really kind of step-by-step instructions on how to use the tool, and there's also a video tutorial. All of this can be accessed for free on the website. The links are here. As Christy mentioned, I'll be PDFing a copy of this presentation where all the hyperlinks are active and will jump you to these references and also other ones I'm going to be coming across or talking about later in the presentation. Yeah. So again, all free. Everything can be completed in under 30 minutes. When we look at the success of the program, in terms of the RLP calculator, since it was first rolled out in 2023, there have been at least 85 views per month from individual municipalities, all the way February, again, right through June. There has been 150 students that have registered for training also since the inception of the program. And when we look at kind of the RLP or the recommendations for this year, kind of looking at zone 4, I guess not only this year, but going back to when the model was being developed in 2022, we see some trends. And when we look at comparing them to the fixed dates, again, March 1st to April 30th, most commonly used in Southwest Ontario, we see if we're using those fixed dates, we missed the window by 10 days. So we're 10 days late. Essentially, we'll see an increase in pavement damage that's going to shorten the pavement life and require additional maintenance. And then on the reverse side, on the reverse end, there would be 14 days where they were held in place too long. That's coming at an industry economic cost of not running those full loads. When we can also look at kind of the other zones, zone 3, using the model, we would have seen just recently, May 17th, the model is predicting removal of the reduced load periods for that time period. Oh, now I go. Sorry. So really, so we know we can be early, we can be late. There's potential for damage, but really, what is the impact? So again, it's one of my presentations. I have formulas for you. I'm going to kind of walk you through kind of and explain sort of what's happening here. So again, we're going to be comparing it to fixed dates. Again, zone 4 for 2026. There would have been 10 days where they should have been in place, but they weren't. So we're adding damage, and then again, removed 14 days, or we're in place 14 days too long. So what we needed to do was create a pavement. I realize that the pavement that's sort of presented on the left-hand side is an over design for a low volume road, but it was kind of necessary for the way the calculation works. And we can draw some conclusions sort of from that. So we see 90 millimeters of asphalt over top of 150 millimeters of granular A and 400 millimeters of granular B. So might be something a little more typical, kind of class 3, higher volume roads. But when we look at kind of defining this in the way pavement engineers and designers think, they'll give us kind of a structural number of 3 or a granular base equivalent of 600. In terms of traffic, again, kind of looking class 3, let's assume 1,500 average daily traffic, 4% trucks, that would give us 60 trucks a day. We're going to assume kind of some loaded conditions using those load equivalent factor calculations. When loaded, an LEF of 3.9, and during the reduced load periods, it'd be reduced to like a value of 1.1. So what we see on our right-hand side is essentially the equation that's going to give you kind of the life cycle or lifespan of a pavement that came out of that AASHTO road test. Again, late 50s, early 60s. So trying to explain some of these values, W, that W sub 18. So that's really the combined easel load over the pavement life cycle. So from that, we're going to know how many loads can be applied to our pavement. Moving across the equation, we see a Z sub R and an S sub naught. These are really statistical terms that are there for reliability and confidence and standard deviation, sort of model defaults that were sort of built into the equation to define how accurate you want it to be. SN, structural number, really expresses pavement strength. You see the delta PSI, or pavement serviceability index. So this is kind of representing the change in condition over time. The value of 2.2 kind of represents the change from a pavement that's in good condition to the later stages of fair or early stages of poor. And the last value, M sub R, or a resilient modulus, kind of relates to the strength of the load carrying capacity of that entire structure. So I have two numbers highlighted, and these were kind of trying to look at running an overloaded case, so that LEF of 3.9 during a period when it actually should have been 1.1. What we see is a decrease in easel life. Under normal conditions, we see our pavement would be able to respond or be able to handle 312,714 equivalent axle loads. And in its weakened state, running again, a fully loaded vehicle, 7,277. So what this is going to equate, even though it's only like 10 days a week, over a period of years, we're going to see a shortening of that pavement life cycle. If we tried to use the formula again with something I guess a little more lower volume, we're going to see a typical life cycle that might last 10 years, and the overloading, we're going to reduce it to about 8.5. So that's the model in a nutshell. But like, where do we go in next steps? There's a couple areas where I'd really like to see this move. So during our spring thaw, we have reduced load periods to account for the weakened state. During winter, our pavements gain additional strength from being frozen. The ability to create an extra or a secondary model that would allow for a winter weight premium, where you could potentially look at increasing that max gross axle weight by up to 10%, or maybe even a little bit higher, and then predict onset and removal times for that. So again, further expanding that economic sort of side, providing value to industry, and still not adding any additional damage to our roads. Would be, I guess, the first place I'd like to take that. The second is kind of looking at incorporating the MTO model into the Winter Web app. The Winter Web app, I guess, is a system or a program that's provided by Good Roads to our members to help develop winter operations plans, monitor your resources during winter, but then also has a paid subscription for weather data to ensure kind of MMS compliance. If we're able to sort of move that within the Winter Web app for those users that are subscribed to the weather data, the ability to then also populate the model and get exact predictions for your specific area based upon the weather that you're experiencing, I guess would be another benefit. Want to also highlight some best practices, kind of when we look at ensuring strength or adding additional strength to our roads to help during this time period. The first, really looking back to compaction, the importance of ensuring that all our pavement layers are asphalt or surface treatments. Then aggregate layers are compacted to 95 to 98% of that maximum dry density. In terms of drainage, we're going to ensure adequate crossfall. somewhere in the neighborhood of 1.5%, 2% for asphalt, be 4 to 5% for our gravel roads. We want to ensure that our ditches are clear and free flowing, so no debris, no obstructions, and ensuring that regular routine maintenance, so crack sealing and grading, is done to help keep moisture out of our pavement structure. And also look to base stabilizations. This can be done sort of chemically through the use of lime, Portland cement, asphalt emulsions, and now there are even some proprietary products that will help increase the strength of that pavement. We can also look to mechanical terms or mechanical methods, so things such as geogrids that are going to restrict the movement and increase the strength. Ensuring proper aggregate gradation and aggregate properties, so crushed faces, that's going to promote aggregate interlock and again increase strength. And when necessary, rebuild those weakened sections. In terms of winter, we want to be able to maintain or ensure that the road surface is undisturbed. We don't want to be digging into, if it's a gravel road, we don't want to be digging into that gravel surface. We also want to be able to remove windrows from the edge of our roadway. So we're going to eliminate the bathtubing effect or the trapping of water during the spring thaw, and also push back the snow as far as possible. Lastly, in terms of loading conditions, the ability to reduce tire pressures. This is going to then increase the contact area of the pavement with the road, and it's going to distribute the load across that pavement structure. I have two quick additional slides kind of highlighting the NEDRA better practices that are both applicable here. The first, our co-winner in 2025, the Township of Oro-Medonte, for their work with the County of Simcoe and their neighboring lower tier municipalities for the adoption and coordination of the MTO's reduced load period onset and removal model. We see a whole bunch of benefits there, data-driven approach, and really getting those onset and removal times correct. The second co-winner, the Township of Center Wellington, who piloted a bioresin or a plant-based stabilization process. There are many benefits sort of to this, to strengthening the base somewhere, but increasing the granular base equivalency by 2 to 3. With that, you see reduced deflections, improved freeze-thaw durability. So the material stayed on the road. We weren't seeing aggregate loss. It's estimated an increase in pavement life of 5 to 8 years. And it was all done for the approximate cost of adding 150 to 200 millimeters of granular material. On the right-hand side, we kind of see the process, pulverization, the applying of the material. It's spread through greater compacted. And then in those final stages, it just looks almost like a wet granular material. The second theme, I want to highlight rural road safety. As since last week was Road Safety Awareness Week, a couple things I want to highlight, kind of Good Roads' role in advocacy. We've been advocating to the provincial government for a funding program, really a rural road safety initiative. Why this is important, when we look at the OSAR data, so Ontario, I can't think of what the acronym stands for at the moment, but it's the Ontario Road Safety Accident Reports. In 2021, there were 561 fatalities. 234 of these occurred in rural municipalities. What makes this more concerning is that our rural areas only constitute 17% of the Ontario's population. So what we have in terms of the initiative is asking for really a 5-year project and funding in the neighborhood of $183 million. The goal really to reduce fatalities and injuries on our rural and northern roads. The World Bank was able to quantify that a $1 investment in road safety audits has a rate of return of $36. So the importance of doing this work. The initiative and program built on sort of 3 grants, the first being kind of a road safety audit, looking to help municipalities identify those safety issues and recommend improvements to reduce the crash risk and severity. The second, infrastructure grants. So this is to help offset the cost of implementing those countermeasures to identify those additional the identified concerns during that road safety audit. And lastly, analysis grants to monitor and evaluate the implemented safety improvements. There are, under, I guess, rural road safety, there's also a number of programs and countermeasures. Going to quickly kind of fly through some of these, but Good Roads has a road safety audits guidelines, has produced a set of road safety audit guidelines and also training that has been now rolled into what we're calling Road Safety School. It was introduced last year, and approximately about 50 students went through some of the courses that were offered. It's being offered again this year, October 6th through 9th in Oakville, where this year we're offering 4 courses. Again, kind of road safety audits, really learn that assessment process. The second course, looking at road safety barriers, looking at how to design and install these treatments. The third course, the design for active transportation, looking at protecting those vulnerable road users, pedestrians and cyclists. And the fourth course, road safety analysis. So really looking at methods to identify the risk, prioritize countermeasures, and analyze the outcomes. The second program I want to highlight is the International Road Safety Assessment Program, or IRAP. What this is, it's a data-driven approach that really goes beyond the road safety audit and attempts to quantify the safety condition of your roads using a star rating system. 1 star, it's a poor road. 5 is a good road. It's classed the safest that it can be based upon today's standards. Evaluation is done through 50+ metrics, looking at things like your road design, intersection design, barriers, speed limits, lane markings, pedestrians, etc. The goal is to have every road in the US rated as a 3-star or better by the end of 2030. And then there's also a global community that has embraced this program, from low to high income countries, places such as Brazil, India, Kazakhstan, to our more high income, the US, the United Kingdom, Australia. However, currently, Canada does not participate, and we're looking to change that. The last thing I have on this slide is FHWA countermeasure. So 2 of my most favorite, well-used sort of guides, the Rural Road Departure Countermeasures Pocket Guide that was produced in 2021, and also the Proven Safety Countermeasures in Rural Communities 2024. There are links to those, but essentially these are there as they focus really specifically on rural countermeasures and contain a wealth of valuable information, from to identifying key treatments or those countermeasures that are applicable to your municipality, giving you specific details, sometimes installation tips, where best to apply these treatments based on conditions, their effectiveness, their relative costs, if they can be used on a gravel or unpaved road, and also kind of recent studies. So a valuable resource for our municipalities. The last thing, or I guess my last slide, kind of on rural road safety, kind of focused on Vision Zero and safe systems. So Vision Zero has been a buzzword since 1997 when the concept was created in Sweden as a road safety initiative, really to eliminate traffic deaths and serious injuries. So that's the what. And how do we go about it? That's that safe system approach. There's 5 core principles and 5 pillars. They're highlighted on the image on the right hand side of the screen. For sake of time, I'll be relatively brief. In terms of those core principles, death and serious injuries are unacceptable. So there's no trade-off. We need to recognize humans make mistakes. And in doing so, we must anticipate and accommodate unavoidable human error. Human bodies have limited tolerances. Really recognizing the fact that there's a threshold where severe injury will occur. The 4th principle is a shared responsibility between system designers, vehicle manufacturers, policymakers, and the road users. It's a priority that we all need to make to focus on safety. And the 5th principle, the proactive approach, where risks are identified and they're mitigated before crashes occur. And then we have the pillars, kind of that center part of that circle. You're going to notice there's 6. Safe land use planning has been kind of grafted into safe road design. So those 5 pillars: safe road design. So infrastructure designed to protect vulnerable users and also traffic and prevent crashes from happening. The idea of safe speeds. So limiting the speeds of our vehicles, that if crashes were to occur, the likelihood of survival, there's a likelihood of survival. Safe vehicles. So the idea that modern vehicles need to be equipped with safety features to prevent collisions, but also protect the occupants when a crash inevitably does happen. The 4th pillar, safe road users, kind of looking at enforcement and education to bring about compliant behavior. And last, post-crash care. So that rapid emergency medical response and trauma care that's vital to saving lives when these accidents and injuries occur. This is the one area that's often overlooked. Now, to support progressing through these, there's 2 additional resources I have on the page, on the slide. The Transportation Association of Canada, or TAC, really think that of similar to Good Roads, but on a national scale. They have a wonderful primer and developed a webinar on that material to promote a greater understanding of Vision Zero and safe systems. It's absolutely fabulous. It's also free. The link's there. And lastly, the National Center for Rural Road Safety. They just completed a virtual mini conference that ran for 2 half days. There were 6 sessions, 18 presentations that discussed both the state of the practice and the state of the art of rural road safety in the US. Those videos and slides are also available and can be accessed through the virtual mini conference link. The last thing I want to leave you with before we go to some questions, just some additional resources. These are things that I go to, again, daily, weekly basis. And some great information for your municipalities. The first being back in 2024, Good Roads hosted a low volume roads workshop where we discussed everything low volume roads. Those videos, I guess videos were recorded during the day. It's the morning and afternoon sessions. There are links there. There's a little over 7 hours of great information that will help you manage your low volume road network. Additionally, the National Center for Rural Road Safety talked about them at their virtual mini conference. There's also lots of wonderful resources and training available, once again, related to, obviously, rural roads. There have been 2 key conferences that have been instrumental. industry, I guess worldwide. I guess the first being the TRBs, the Transportation Research Board's Low Volume Road Conference back in 2023. And then in 2024, they had a roadside safety conference. So again, great information applicable to Ontario municipalities and the way that we deal with our low volume roads. The FHWA's Gravel Roads Construction and Maintenance Guide. Wonderful document. Again, the way our roads are best managed are sort of highlighted throughout that document. And lastly, I'll leave you with the University of California Pavement Research Center has two tools available. The first being a chemical treatment selection tool. So on the right-hand side, that lower right image, we see kind of the predicted performance of our gravel roads based upon the gradation of your materials and also your plasticity index. They've been able to quantify how that road is going to predict or how it's going to perform, whether it's going to washboard and rut, your surface material is going to erode, will it ravel, or is it going to be dusty, or do we have really a good gravel road? That's there. And then also with that, if you fall outside of that good, there are recommendations based upon what kind of surface treatments that could be added to bring the performance back or closer to that good characteristic. And with that, I want to thank you for your attention and just kind of leave you with better data will help us make better decisions that's ultimately going to end up creating better and safer roads for us. Yeah.
Great. Thank you, James.
You're welcome.
So we will open the floor to any questions now. There's none here in the chat. Do any of the participants have any questions for James? You would just need to unmute yourself and let us know. I'm not seeing anybody unmuting. I'll just watch the chat for a quick second here. So as we mentioned a couple times throughout, we will make sure that those slides that James presented today do get sent to you along with the video recording of today's session. So all of that information that you digested in the last little bit here, we can rewatch and kind of maybe get a better handle on. So with that, I guess like I said, if there are no questions from the floor, I do want to thank everybody for attending today. If you're joining this afternoon session, look forward to another great session with Kelly this afternoon. And otherwise, I wish everyone a great day. Thank you.
Well, thank you so much.